What I'm going to talk about today is I've probably have 5 or 6 different talks in the last 12 years on this similar topic, and I think eventually if there's enough reference material out there, people will be able to find it and we'll get less questions about why things do what they do. As you can see on the mailing list, we were answering some of these questions just in the past 3 or 4 days on the list. So what I'm going to talk about is why, when everybody asks, why do you even have a reference kernel? So one of the goals of the talk is to get some more information out there about why a reference kernel is important. Highlight what, in fact, linux-yocto does in the project. Discuss a few of the lesser known elements of the reference kernel, again, to hopefully head off some of the questions. Show how you can extend it with your own either configuration or BSPs or different things. Talk about some of the use cases and then cover, or at least introduce a few frequently asked questions. So you know, why a reference kernel? And one of the reasons that from the very beginning we always had a reference kernel in OE core was if you didn't, there would literally be a kernel, and there was a kernel for every single possible version and every single stable version available. You would have a full, not even discrete list of versions. You would have an analog version of a number of versions going off forever, including vendor kernels. We all love, Phil loves a good vendor kernel. In upstream kernels that, what's that? I don't know why Xilinx has one, because I have Xilinx branches in my kernel, but we won't cover the name. There would be upstream, even kernel, people that give you a kernel that meant well with an upstream kernel.org, that they've picked you know, a version that wasn't in LTS and it's EOL'd, or they did stable updates for a few months and then got bored and it's, you know, .0, .1, .2. So anyway, there would be everything. And so the other thing that so it's to at least try to create some momentum and center of mass around a few particular versions, every release at least. It also does provide as a baseline for security and maintenance with a predictable update and predictable cadence and sustained updates. I'm still doing updates to some of the 4.x kernels that we released way back in the day. I have a slide on sort of the rate of decay of my updates cadence. And that we do try to minimize this, but it is a place for us to do some embedded specific changes to the kernel. And there's not very many of them left. I'd say 10 years ago there was a few more. The other things that it does is it allows us to exercise the kernel workflows. So whether or not you use the actual kernel, the bitbake and the OE core support is exercised on the auto builder using the reference kernels. It lets us validate those tightly coupled packages. And if you want to know which ones those are, just check the mailing list and you'll see the ones that I send updates to roughly every 2 months. So your system taps, perf, LTTNG, these ones that are a little bit more susceptible to kernel versions, we make sure they work and make changes to make them support what somebody else might be doing in their kernel. It can be used, and people do. It's a jump start if you want to. You fully can use it as a production or commercial offering baseline. It has vertical, if you will, specific configurations and testing. You know, it's had the preempt RT patch since the very beginning. It has a tiny configuration. It has a developer mode. These are also some of the lesser known things of it, I would say. We build something called the standard, which we are Yocto standard configuration. And there's branches in the repository that are just pure kernel.org. One of the other things is it's how we test the configuration and the fragments and the merging in that model as well. And from time to time, in particular from Wind River, they like to send us their SDK ports and their BSPs so we can maintain them in one place, give them the stable updates, and anybody else can use them if they want. So it's a collection point for some contributed board support. The other thing that it does is, you know, we do detect and try to fix issues early. So even when we released with the 6.1 kernel, the previous release, the dev kernel was on 6.3, I think. And I was working ahead to make sure that if somebody took the older release and they wanted to use the 6.3, their own 6.3 kernel, we would know that perf LTTNG, libc, headers, all the things would actually work with the kernel. So even if we only released a slightly older version, the dev kernel always marches forward to test the latest. And most important, it does help support the validation and testing of the entire ecosystem, and we, for better or for worse, get stuck fixing the hard to find problems, as witnessed by the week and a half a bunch of us spent recently trying to figure out why 6.1 stable around .18 started doing intermittent hangs on x86 boot. Nobody else apparently was seeing it. We were seeing it enough for it to be really annoying, and sure enough, it was a auto-selected stable backport that was breaking the clock on x86 boot. And it managed in a span of 3 days to get to basically every known stable kernel version. And so we headed it off, so if anybody is using a kernel.org stable, you probably have a reverted fix due, in fact, some of the work that we did to track down that problem. Some things that would be nice in the reference kernel would be to expand some of the boot testing coverage, because we do mainly do it with QEMU. We're looking at refreshing some of the reference boards, which might get us some different and more hardware. One of the pain points we have is some of the image assembly classes in OE core, in particular fit image. Everybody is in there whacking in their conditional bundled corner case, and we don't really have great self-tests or way to test it, so we kind of trust that you're not breaking somebody else for the most part. And so some of these things would be nice if we could work on being able to test them more with the reference kernel, and a little bit of streamlining of some of the developer workflows, because
Okay, everyone.
if you've ever bumped
Bruce
into a
Ashfield is
hardcore kernel developer, he'll tell you that there's no way you're going to get him to build his kernel with bitbake, wrapping the build process and doing anything. So if we could streamline some of those entries, some of those flows, maybe we could get a little bit more hands-on work with the kernel. And of course, we've been trying for a while, but it would be nice to get some more kernel-specific nightly smoke testing and build testing. So some of the K self-tests, stress tests, those sort of things. And then do our own performance tracking over time, so we could notice if another hard to find problem shows up in the kernel, if networking performance goes down, if something's broken, and we don't really have our own metrics. We rely on sort of the general kernel community's metrics for those. So everybody always asks, why would I care? Why would I help you? Why would I do anything with linux-yocto? What's in it for me? I could say, well, you don't have to help because they're opt-in. You could have your own kernel, that's fine. They always say, I could easily do X myself. I could go grab the stable update and I could merge it. Definitely, you absolutely could, because sometimes it's not even that hard to do. But if 10,000 of us still do something that's easy, it's still a lot of effort that is being duplicated everywhere. What's in it for you is that the broader multi-machine architecture and workload testing, it benefits everybody, because maybe you're going to have a different BSP in the future. Maybe you don't even know you're using a common subsystem. Maybe we're testing some TPM code in one of the paths, and you don't know you need it yet you will. So the broad testing is providing you benefits through different either user space packages, layers, bits of the ecosystem. And one thing that is it provides hopefully at least a little bit of a collection point for some configuration or fixes and features, because if they're sprayed across 72 layers and 5 dynamic layers and 3 BSPs across the ecosystem, layer index can help you find some of them, but it's still not always ideal to track those down. Again, we fix the problems before you know you have them. So if you're booting an x86 on 6.1, 18 plus, you're welcome for it not hanging on boot with a clock. It allows us to interact with things like kernel CI, some of the test infrastructure projects, because we can put our CVE tracking and those sort of our information into those. So it gives us a chance to promote the Yocto project, promote the community, and let them know what we're doing. And of course, we do use case specific tuning and work. So the stuff I do, particularly around containers, virtualization, and RT, are tested. And of course, you get security updates, and we will support you within reason if you have issues with it. So I have my own stopwatch this time, so I know I'm 10 minutes in. So how does it work? So I've done long talks on this before, so I'm going to go through this fairly quickly. So you can see my Linux-Yocto reference kernel maintenance and kernel workflows talk from May 2021. Nothing's really changed since then. There's 3 versions per release. We pick an LTS, the current. Sometimes LTS and current are actually the same. So my statement of 3 versions per release is not true. It might be 2. And then the dev kernel. We support our major architectures, and the version selection is document. How we pick it is it's predictable, and it is documented on the Yocto wiki pages somewhere. If you asked me to find it, I probably couldn't, but we wrote it. So the way that it's managed is you can, I guess, rest assured that it's based on my first 14 years of my career doing kernel maintenance for an embedded operating system vendor, and we tried about everything until we landed on a similar maintenance model to this that seems to scale up through the 3+ kernel versions, 20+ BSPs, and 3+ kernel types at any given time. So I'm supporting something like 280 different variants at any one time, sort of by myself. So it scales pretty well. The update cadence that I was talking about. So on a weekly basis, I am updating the dev kernel with the latest RC, the stable kernel. That's usually on the current and the most recent LTS. I do that weekly, so I'll pick up the k.org stables. Monthly, I do the stable on sort of the older LTS. You'll see me sending 5.4 updates less frequently than I used to, for example. Bi-monthly, we pick up the latest upstream kernel. Per release, I go through the extra effort of putting out that new versioned reference kernel. That includes a lot more testing to make sure everything works perfectly, if you will. Bug fixes, of course, on demand whenever there's a problem. And user space, the tightly coupled packages, we update them along with any of the above if they have any trouble. The kernel configuration, fragments, and things that power the underneath there, that's per released, and they're always refreshed for the most current and the dev kernel. So there's the one we've released, and they've been validated against the latest development kernel at the same time. And of course, new feature fixes on demand. I'm always merging changes to the configuration. The Linux-Yocto repository, it used to be 2 or 3. We used to do a repository per release, but there was complaints about having to fetch a whole new kernel repository all the time. So now in the Linux-Yocto repository itself, there's mainline, there's stable, there's real-time, tiny, Yocto, and SDK sort of variants of the BSPs and the branches and the support. The only separate repository, and it doesn't even need to be separate anymore, it is simply because the dev kernel can be rebased and it's not supported at the same level, so having it separate has its advantage. So dev is a separate repository, Linux-Yocto dev. But you can just look at the branches in the tree at any time and you can see what's there. The mainline kernel, completely unchanged, plus it actually gets the stable changes as well, so my slide's slightly wrong, is like v6.1 base. That's kernel.org 6.1.x, whatever it is. The next one has a different branch suffix on it. That's where we have a few of our Yocto project specific changes. That's standard base. And then the preempt RT layers on top of that, so standard preempt RT base, standard tiny, and then standard, and then there's SDK and BSP branches on the end of them. So those are all in the repository at any time being updated with the various stables, dev kernels, and things like that. So branches come in and out. The Yocto kernel cache is a separate repository, and it holds the configuration. And if there is a branch Yocto release, that is the version that matches. That's the kernel configuration that we validated against the release kernel. And that's graphically what I just described. So if you're ever looking for something in there, you could base your own work off any of those branches, and they would still be all updated with stable and bug fixes and anything that we find. So, and that's the current 5.15 and 6.1 support matrix, if you will. The types of BSBs, configuration, and use cases that we support in the reference kernel, there are in-tree BSPs, if you will, meaning they use one of the branches that I just mentioned. They use that tree, and their configuration is in the kernel cache. So there is that chopped up configuration that we test and we validate. So that's an in-tree, if you will, BSB. There's an out-of-tree BSB, a lot of people do, and in that case, the code is either all upstream or the SDK is in linux-yocto, but the configuration is sitting in a layer somewhere. It's not in the main configuration. So it might be using a def config, or it might be using some kind of different configuration, and it's sitting in a BSB layer somewhere. There are SDKs, and that usually adds vendor-specific changes to the kernel, and it makes my life miserable when I merge stable changes, but they are, if you will, firewalled off from the rest of the kernel. That's why they're always in a sub-branch of the tree, because that way somebody's SDK changes aren't going to break another BSB. And there are user space and mapping of user space, if you will, or distro features to kernel configuration. That can happen in, you'll see configuration fragments and layers that are looking at machine features, and they have a kernel BB append, and they add either kernel features or fragments to the source URI, and they do the configuration that way. So you'll find some of the configuration fragments floating around different layers that support the merging of fragments by the kernel Yocto workflow. I won't go into this detail, but this is the simple. It's simple, right? This is the build overview. These are the extended steps are the one in orange. Some of them are value add. Some, I don't know, maybe they're not. But you can see the configuration. It comes from this kernel cache thing. That is the patches, the configuration, these descriptors. You get the kernel support, the kernel source, and the in-tree def configs through the linux-yocto tree. You get recipe space configuration, which is either on the source URI, like I mentioned, or through the kernel features variable, and patches. They go into this thing that gathers up all the kernel metadata, and it puts out a patch queue and a config queue. Well, the patching queue patches like anything else to the actual source. It allows you to do a few extra things that like merging some changes and patching metadata, but it's relatively the same. And then this kernel config me runs the upstream merge config to put all of the configuration fragments together, produces your .config, and then we run this extra thing called kernel config check, which will warn you if some of the features that you were interested in did not make it into the final .config, and it attempts to output why that might be the case. So if you have something that is important for a feature in your user space or to boot your board, that's the step that will warn you if you go through this process. And then other than that, everything is the same once we get to the build and the packaging step. So how can you extend or use the reference kernel? Well, you can define your own recipe space BSBs. There's a few different layers that do that. In that case, it means they are providing their own entry point and board description in something that the kernel Yocto build looks for and it finds, and that's the entry point into what branch to use, what patches, what configuration fragments to find, and that sort of thing. So you can extend it without ever touching the kernel cache or linux-yocto itself, and you could build a def config or a fragment-based BSP against linux-yocto. Like I mentioned before, we have multiple kernel types for each machine. You can build pure upstream kernels sort of directly. You can do it with the stable updated branches, or you can do preempt RT tiny or developer, and that's just a matter of selecting the kernel type in your build, and it automatically switches to the right branch and builds the content. The configuration metadata can also be shared even if a reference kernel isn't used, because it's not inherently tied to linux-yocto. And you can, like I mentioned before, you'll see I have a whole bunch of them in meta virtualization and meta security, and Armin has some in meta security as well. So you can extend it without ever needing to touch or fork or otherwise manipulate the repositories. We have done some BSP extension examples in previous Yocto dev days where we showed how it can audit your config and you can break it and it will warn you and that sort of thing. So there's some hands-on examples out there that are still accurate. And you can thank Tim because I think he cleaned it up last. And of course the Yocto project documentation has all of the details, possibly too many. So if send patches or ask questions if what is in the documentation is not clear. So I'm just going to now quickly start to wrap up on what we're actually doing for the reference kernel testing. So the Yocto project auto builder is building, hundreds and thousands of builds of linux-yocto for the supported QEMU targets and various distro configurations, thousands of them a week, and doing the boot testing under stress. And that's where we find things like intermittent boot hangs on x86 when the clock would go away. So there is a significant amount of build and boot testing that happens on a weekly basis. And of course, some of the different ecosystem layers are providing use case specific kernel configuration and testing. Again, meta virtualization and meta security in particular are leveraging that to be able to do some extra testing on the reference kernel. We of course test more than just the kernel. As I mentioned before, the tightly coupled user space applications are tested as part of each release, and some of them even on the nightlies. So LTTNG perf system tap, virtualization and containers are constantly tested against the reference kernel. So that's all of your UAPIs, your syscalls, and that sort of stuff is indirectly tested through the big stack of the framework on top. Some of the boot and the image types are tested, but refer to my would be nice slide where I said it'd be great if we could test more combinations of the boot testing and image assembly, because those are the ones that somebody says they broke and we don't even know how long ago they broke. The kernel workflows are tested, whether it be developer, production, debug, and reproducibility. We drive through the testing of the reference kernel. So I already know that 6.4 has a perf reproducibility problem that has popped back up, even though we haven't released it yet, because we test reproducibility against the dev kernel, and it's waiting for me to fix when I'm back from the conference. And of course, we've always done CVE updates and security updates to it, but now we have turned on the CVE tracking for linux-yocto, so you'll have an idea of what, if you do use it, what the CVE profile of the kernel is, and you can thank Ross for some of that, because they're all in there manually updating and excluding and telling us, it's challenging to map kernel CVEs to versions because the upstream databases aren't always accurate. So there's a not insignificant a bit of effort that's gone into that recently to make sure that we have fairly good CVE tracking against the kernels that we're producing. And from my last slide, so this is we get them on the mailing list, we get them at the conference, it's like, I just want kernel.org. You can absolutely do that, and nobody's going to stop you. Or you can just use version base, in linux-yocto and get all the stable updates automatically. The reference kernel in no way, shape, or form is ever intended to replace the upstream main repository. It is just a single source of updates that is tested in the project that you're working on. Therefore, it is probably a little bit more predictable if you're working with an ecosystem. We get lots of comments about I don't like the way X is done. In particular, when somebody's using a def config, it uses an all no config, because when this was created, def configs were not really def configs, they were full dot configs. So we had to turn everything off, and then it turned everything on, and so there's problems. But so the point I say to that is, it's A, it is documented, and B, like the tree, the configuration process is completely opt-in. Anything that is common or always useful for any kernel recipe that you're writing is already in or goes into the kernel BB class, kernel module split. All of the non-kernel Yocto classes is where all of the common fixes go. So anything that we find that's useful through this, it doesn't just go into the linux-yocto or kernel linux-yocto recipes or the kernel Yocto BB class. And my favorite is, why is my configuration option being ignored? And that's because we're mean and we just ignore options once in a while because we like to see how long it'll take you to find it. And the answer is use the kernel configuration audit tools. It'll tell you that you wanted to turn it on, but one of your other options probably selected it to no. And that's why it's not in the final config. It will tell you things like that. But no, it never ever just ignores options. And I think this goes into what we were talking about earlier. It's like, hey, my vendor BSP uses version Y. As a first step, you can ask them to track at least the reference versions that we are testing the project against. They don't even have to use the tree. It'd be just fantastic if they would do 6.1 on Mickeldor, and then at least we know that there's a hope that the whole system will work well together. The second step, you can ask them how much of their BSP is upstream, because the more they have in kernel.org, the easier it is for us to actually fully even test it on the auto builder or do other kind of extended testing with it. And an alternate step is ask them to contribute the BSP to linux-yocto or significant features that they're hiding, because at least that way we can get them halfway out into the open and then hopefully encourage them to get them all the way upstream. And the other question is, how long is a version maintained? And as of now, unless even on some of our EOL releases, as long as they're still doing upstream stable updates, I will pull them back on that sort of decaying timescale back all the way to almost any version we've ever released with the project until I finally find I don't have. My scripts are fairly efficient at it, so don't fear for my time. I can update a lot of stable kernels fairly quickly. And that's it for me.